This is an interview with Yotam Azriel, a friend of mine and co founder of TensorLeap, a company focused on explainability AI. And this is also the goal of this interview. We cover explainability AI, what it is, how it works, and how to do that. I hope you enjoy the interview. What is your academic background and your background outside of academia?
I have no academic background at all. I started to work um, just out of nowhere. I did some research in some university in the south. I started my scientific professional life very early. I started to work in IT companies since 16 to do some research in different places. Um, so I started in physics mostly department. I did some um, magnetic fields in ferromagnetic materials research, how magnetic field is floating, how you can improve transformation of energy. And I worked on some patent on a few researches. I got a reward from the Israeli president for one of my research when I was about 16, and then some company found me, called me, and I joined them. It was a power mat. We did wireless charging technologies. I had a small venture back then. You raised some money, we tried to work on some kind of neurotransformer. Um, and then I joined the Israeli army for intelligence. So I developed some techniques to detect stuff. And from there, I moved to the Nuclei Research Center, which is a research center in Israel. And I think that it's I had one conversation with one crazy physicist that came to me and told me I was sure that I wanted to be huge physics. I thought that about Bohr and Einstein and Schneider, and then this guy came to me and told me, "Yotam, there is no and there will never be again any big physicist. Those people are." And that it's thousands of people that working on a very complex and and a very comprehensive theory, and everyone changing very small piece in this huge theory. So you won't be a physicist. But by the way, this field of biological algorithms that can learn seems to be a serious thing, and you should go there. So I started to focus mainly on AI back then, and I just understood that this is going to be the path of my life. So I never went to university to do any kind of degrees. Um, but part of my professional life, I got a lot of experience and a lot of tools that allowed me to conduct very advanced research. So I'm very hands-on. I think I'm calling myself developer, data scientist, maybe. I don't know. I did a lot in the last 12 years. I did some CPP programming and algorithms and modeling and autonomous vehicles and algo trading and cloud management and different kind of stuff. And all of them, I choose every position in my life in order to become the person I need to be in order to open a company. Like I had a vision that I want to do something, and I knew that I need to understand a big percentage of the stack in order to be able to know what actually happening. Maybe I'm free control in a way. Uh, so I chose very specifically and in attention specific job that will make me to gain those tools. By the way, like and this is my way to learn. Like if I want to study something new, I'm finding a job in this field.
And how do you find that job that you still don't know much about it yet?
Don't know. I think I have something compelling and convincing in job interviews. I'm not sure why people believe in me. I never understood it. But I'm constantly getting jobs without any background in a specific field. I got my first job as CPP programming for a very specific and very complicated alg- evolutionary algorithms for detecting and tracking after thousands of sensors without writing one line in CPP. But they just convinced them that they can learn, and they learned in 2 weeks, and they did well. It worked very well. And also in the algo trading afterwards, and autonomous vehicle never did neural network before. Well, not for vision. Did some neural networks around 2014 for specific data. But yeah, you just get in there and people have faith. It's very interesting. It's very different. Like you cannot predict it, right? You just trust, and it's happening. So,
Yeah. And how do you learn these new fields? For example, just I know that a lot of people, because of ChatGPT and other cool models, want to transition into artificial intelligence, and you've been learning by your own. So I assume most certainly with online resources or books or something. Would you have anything you'd recommend for someone to get into the field from a different background?
well, I got into the field intentionally, and I devoted myself to artificial intelligence around 2014. And back then, you had maybe, I don't know, 5 to 10 courses online in Coursera and Udemy, and I did them all. Uh, Watched all the videos that had information in YouTube and read anything. And very quickly I understood that reading a paper, it's amazing. It's an amazing method. I had for a few years an habit to make a coffee and read one paper at least every day. I would wake up, and I got to times that I could finish understand a paper in 20, 30 minutes, maybe 40 minutes if it was a very long one. But every day I would read a paper. I make myself a list, and it's amazing. And then it's nice, people not just people writing the papers exactly for that, and it works. Like papers is amazing. And try when you have a work that requiring from you to know stuff in order to succeed, your understanding of the material is different. Not only because you're going to use it, also because you have need to understand, and then the understanding is coming with pleasure because you have a need for it. So if you want to study something to find a job, I think it's much effective than go to the academy maybe.
Mm.
Now, when I'm developing a certain product, and I understand that in order to do that well, I need to understand in magnetic field, I have a lot of incentive to do whatever I can. When I'm managing to understand something, it's not just for the sake of understanding. I'm progressing towards a target.
Yeah, so you would recommend to have some kind of incentive to learn something, like the additional stress will help you better understand and process information, I assume.
Yeah, like find a reason that you want to study it, make it tangible as you can. Don't just say I want to cure cancer. It's important to cure cancer and start to study. Make it tangible, like
Yeah.
like your study and the effort you're investing gonna make a difference
Mm.
in something that you care about. And then when you study, you also will have different kind of energy, different kind of motive towards it. But you also will, right, when you'll get there, when you'll get to a new understanding, when you'll manage to figure something out, it will have much more meaning
Yeah.
beyond this pleasure of understanding stuff. Yeah, I think that for me it's very, very important. I'm not sure I would be able to succeed in university. I'm not sure that I'm this kind of material, but I could write really great papers when I was 16, and I could solve very complex issues. Uh, I did a lot of technology for the last 14 years, and very complicated ones. And still, I'm not sure that I would handle university. It's not. I'm not sure I have this type of brain.
Regular university is definitely different, and not it's unfortunate because a lot of people are in your situation as well, where the classical path with college and university isn't suited to them, but they basically have to do it. and you are demonstrating that you don't have to do it, but you may be a special case with a very high intelligence, so that may not be to anyone.
I'm not sure I'm a special case. I think that I'm a very lucky case. I'm truly think that I'm not sure that I'm truly think that I won't be able to pass university well as many people are. But I am a good developer, so I'm just wondering how many people that couldn't pass university and are possibly good developers just miss the opportunity because of expectations of
Yeah,
society, right? And it sucks. We have great people around us that could achieve great stuff, but just because they're not fitting this way of thinking, those academic organizations are expecting everyone to think, it just kill their opportunities. I think that I just had a lot of luck. Like if we'll move and find all the very specific event that happened in my life that allowed me to start working IT very early, work in very important project in the Israeli government, achieve an experience in different startups in my lifetime without a degree, and opening this startup, TensorLeap, like the chances is very very low. You can understand that it's all about throwing the dice properly. There is it's much of it. And then maybe I'm a bit more uh, yeah, trying more than more most of the people. I'm pushing really hard. I'm not resting. I'm working. I think in average in the last 12 years I worked more than 12 hours a day.
and it's mostly because of the motivation, where you have a goal and you basically need to learn and to produce something. It's just like, I very understand what you are saying, just because I do the same thing but with YouTube videos, basically, where I try to force myself to learn more efficiently by doing a video around a specific topic, which helped me a
Mhm.
lot during my master's, just because my master's was very similar to a PhD, and so it was at my own pace, and I just wasn't able to motivate myself to learning and reading papers unless I could do something out of it. And so I started doing blogs and YouTube videos just to force myself to read those papers and understand them, and then be able to have some kind of output through that. And so that, I think that's something that is very, I don't know, not precious, but very important for when learning something new. I think lots of people, for example, the ones that are transitioning into AI, should try to have a goal in mind and then learn, rather than just doing courses until, like as you said, back in the days there were maybe 10 courses online, but now there are thousands. So you can do courses indefinitely and never really enter the field. And that's one of the danger that some people get into. And so I think aiming for something applied, for example, just when I wanted to learn how to how to code a mobile app, and so I just brainstormed with some friends on what kind of app we could build. And once I had an idea, I learned by
Yeah,
building the app, which I believe is much more effective than just trying to
yeah,
learn something.
and it makes sense. Then it
Yeah,
just makes sense to study because why you're doing it for, and
yeah.
to act from the right place is it's hard that everyone need to get better in, like to find the reason you're doing stuff. Um, yeah, so I think that I'm calling myself a data scientist for the 12 less years, very hands-on. Um, and now I'm also startup co-founder, which is interesting experience. It's different, hard. Yeah,
Yes, you mentioned the startup is TensorLeap, so maybe we can dive into the main topic of this interview, which is explainability AI. But we will come back to that. First, could you maybe just give us a little introduction of what is TensorLeap, and what do you do there?
sure. So TensorLeap is, we call it applied explainability platform. It's a tool for developers, for data scientists that working on artificial intelligence models. The motive to open the company were, we looked on the world and we saw, even in 2000, when we did it, 1918, we saw how people developing neural networks, and so many parts and critical parts of the development paradigm were relied on guesswork and hunches, and it just disrupted, it just took out all the science from a very scientific process. uh, the way we constructing data sets, we just collecting randomly samples, the way we testing it by luck. If your test set is representing something in production, some distribution of information to production, you might be able to guess what will be the results in total. But so many stuff rely on guesswork, and we try to understand why is it and what happened in this process. um, and we understood that the lack of explainability, it's a root cause for many different parts in this development paradigm. In the idea that the developer using guesswork and hunches in order to progress with their artificial intelligence project. Um, you know, 12 years ago, I worked on the magnetic field project, and we simulated the magnetic field completely. I studied books of physics and studied about materials. I studied about everything, and the simulation of reality were perfect, very unstable because you cannot model reality perfectly. It's very hard, but it was deterministic model, very complex, very huge deterministic models. And then we started to do a bit statistics afterwards in order to round some corner to try to get to a bit more robustness. So you're losing a bit information, you become a bit more statistics, but still in this distance between how detailed and specific you are to how flexible and robust you are, you're trying to find a balance. And then we moved from statistics to machine learning, and we try to, we said, okay, so we won't write all those rules about when it will behave in this way or other. We'll give it the basic features that we decided are important, and then we'll hope that this machine learning will know how to balance those features well. And then we did neural networks, we did deep learning, and we said, right, to this process of feature extraction is way too complex. So I want the model to do it for myself. I'm just gonna describe my model, some general idea of how the dimension, how the domain looks like, on which dimensions the information is distributing, and which way we can extract those features, and the model will extract the features by itself. And slowly, since 15 years ago, we used to write, most of the people write very complex deterministic models, to statistics, to machine learning, to neural network. um, we stepped out of it, and slowly we got less familiar with the domain.
Mm.
If today I need to do the project about magnetic fields from 12 years ago, I won't understand it as well as I did back then, because I won't need to. I just will
Yeah.
write some algorithm that will predict and learn where is the magnetic field, and will do whatever it'll do. I don't care, right? But what happened there is that we do not understand the domain we working on. We do not understand how those neural network works, and so when it failed, you're starting to guess. And when you're trying to teach or to train some model, you need to understand something about how to construct these data sets, what kind of scenarios, what kind of edge cases, population you have, and you're starting to guess a lot. I think that somewhere in this process, from deterministic to statistics to ML to deep learning, we just needed to stop somewhere and say, okay, now we need a different development paradigm. We constantly, like when we did random forest and GBoost and all of those models, you could train in 2 hours thousands models. And you're doing it, and it's fine, and you take the best one, and maybe it works, right? And when you get in results, you can just query some SQL and find most of the edge cases because you have table of features. You don't have thousands and thousands of pixels with some relations in a video. You can find those edge cases with simple queries. But the move from structured data to unstructured data, from tables of information to videos, text, genetic data, um, point cloud, all those unstructured information, just changing so much of the game. Training neural network takes weeks for part of our clients. They cannot train thousands of neural networks and then take the best one.
Hmm.
So TensorLeap is here in order to develop, invent, find new explainability techniques and integrate them within the development process of neural networks.
And could you give a very short and clear explanation of what is explainability in AI? And you mentioned you can give uh, basically practical techniques or real techniques, applied techniques. Could you give an example of one explainability AI technique for the people listening that may not be familiar with explainability AI or XAI?
We can say that there is two kind. People can mean to two different things when they're speaking about explainability. You have explainability for the product itself. Let's say that you develop some neural network and integrating it into a product, and you need to explain your clients why you get in decisions. Those explanations, people expecting to get something in a very human level
Yeah.
explanations. It's a bit harder. It's a bit, we are not there yet, uh, the science, but I believe that we'll get there. The other explainability, which is the one that we are more active in, is just explainability that applies some mathematical techniques on neural network. Most of the techniques are deterministics, and providing some visual assets that will allow us to understand the way of thinking of this neural network, on which feature they used. So, for example, if we'll take a neural network that perceives images, for example, in searching cats and dogs, we'll be able to apply some mathematical operations on this model while it's predicting one specific sample in order to understand which features in the image cause the model to take a decision, right? So let's say that we're inferring an image, we have many neurons, each one of them learns some different features, which mean that every neuron creating a bit more a different projection of the sample on some feature maps, and in each layer we'll get a new representations of the same input. Some of those representations can be used and more correlated with certain kind of prediction of the neural network. So for example, if we'll take the layer in the input and we'll create derivatives for certain neurons, for example, those that represent dog, towards some layer in the model, we'll be able to calculate the gradients between the neuron that predicted dog to all the neurons in the layer. And then we'll be able to understand that this specific neuron influencing the model a lot in order to guess that this is a dog and not a cat. And then by tracing back the activation and finding where this feature actually were localized in, we can understand which area in the image caused this specific filter to fire and the model to take certain prediction. And there is a few kind of explainability. Let's split it to two. There is local explainability and global explainability. Where local explainability is exactly that. It's trying to explain why a model took decision on one sample. And global explainability is in general on all the data set. So for example, TensorLeap, what we are doing, we're tracking after all the activation in those neural networks. We're calculating for each activation energy and entropy. Some of them calculating mutual information between the prediction, between different clusters in the model itself, which allow us to understand which features learn the most informative information. And then we construct in some latent space. We're just extracting activations from different fields that's in the model. We're building some uh, vector database with all the data sets and all the most important features indexed there, and then we're able to search for different clusters and different populations. So, if this process of the model of extracting features, we can rely on the idea that, if it's guessed well, it means that he managed to study some features, and if we can rely on the idea that it studied legit features or some of them, we can use those features in order to define different scenarios in the dataset. So, for example, if we have 1,000 samples that fired in on exactly the same features, those 1,000 samples look alike
Hmm.
because they have the same features, right? And if I'll have eyes like yours, eyebrows like yours, hair like yours, we really look like you. So, um, so this is what we are doing. We collecting all this information on all the neural networks features, and then we projecting all the data set on the most important features in the model itself, and then we searching with unsupervised techniques different population, and then we trying to characterize those population. Characterize. We're trying to find the clusters that the features that express the most a very high information gain with the input, which mean that those population probably tending to overfitting, or we're searching for populations that has low representation in the training set, and then we can recommend the clients, hey, bring us some unlabeled data and we'll tell you which data is better for you to label right now, right? So we're trying to find a lot of populations, and this is kind of global explainability.
So explainability would be used, well, should be used by anyone training or fine tuning or working with AI models. And I assume it's mainly used to improve the results, but also to understand them, or like improve the results by understanding them. And so I wonder if you could maybe give a very specific example. No worries if not, but like on the fly, for example, for the recent SAM model, which was a segment anything model. It's basically just a model for doing segmentation. Um, could you think of one explainability technique that could be used to improve or better understand the results on this specific application?
So, you know all those models are working the same in the terms that there are feature search models. They're all searching features that they can use in order to perform certain task. Each kind of task um, can be analyzed different. For example, if you're running on if you're doing classification and you want to understand the way the model took decisions, you need to understand the decoder parts, and then you know how to run derivatives. For example, you know how to create derivatives from the prediction neurons that symbolizing something towards some latent space in the model. And if you're doing object detection, you can do it in a um, different resolution, and you can create derivatives from each one of the neurons that represent some kind of instance in the image, right? A B box, a specific B box. And in each one of those algorithms, you'll have a different decoder. And by understanding the decoder, you can write a very specific kind of explainability techniques. And it's all the idea. Everything in neural networks it's a process that's searching features from some unstructured dimension, uh, sharing features, generalizing features, projecting the data on a lot of representations, more abstract, more simple to analyze, and then decoding them to a certain shape, or decoding them into a certain representation that we can just apply some deterministic code after and take decisions. Um, and this SAM algorithm, it also has a very specific kind of decoder. And there is different ways to tackle this decoder. You can understand that each pixel, it's an instance. And from each pixel, you can create derivatives because it's instant semantic segmentation techniques. You can create derivatives not from a pixel, but from the whole instance itself, and then understand what caused for an instance to appear, and you'll get different ideas. We did play with it a bit, and because the model is not small, many if you are taking the latest layer, many of the heat maps you'll receive will be huge, and it'll be hard for you to understand. So what we did, we just kept going backward, and we just developing techniques now that constantly going backward in the model, more and more shallow, creating more and more derivatives recursively in order to understand, okay, so this the neurons that in the end of the network was sensitive to information somewhere here, and this neuron were sensitive to information a bit more specific, and then we going back and understanding which feature constructed this very general feature, right? So we'll get heat map within a heat map within a heat map within a heat map, that explaining why specifically this instance was created.
And you mentioned it is basically very similar from one application to another, where it's applied. Of course, it will be adapted to the application, but it's in short similar and using the same technique. And I assume, is it the same for the different architectures as well? For example, if we are doing image classification and we either use a convolutional neural network or a VIT, a transformer based vision network, would they be the same explainability technique, but just the computation would be a bit different just because of the math, but the visualization produced and everything, the same technique will be applied?
There is a ways to generalize those rules, and you must do that. The idea is that it's right. When you take an image, the order of the pixels are very important, and therefore people using convolutions because it's able to find patterns from in such an or in such as order the information. And in other cases, you'll use LSTM in order to generalize the information different. And all the idea in your data, the data distribute in certain way, and you're trying to come up with mathematical operations that can be sensitive to generalization of this information, so the first convolution they made, it's basically sharing the weights from different parts in the image. It's sharing the understanding. It managed to learn a pattern and it's searching it in different places. And when they did transformers, they wanted to share and to be able to share information from concise, non-closed areas in the image. And the idea is it's interesting, and you do need to understand it. So the way um, we when we working on neural networks, we take in the models in ONX, for example, and we're parsing it all, and we completely understand each one of the operation. We understand on which dimension it's creating. It's trying to generalize information, and when you want to calculate, for example, mutual information or entropy of certain prediction, you have to understand the dimensions of the output of those operations. You need to understand on which dimension it try to generalize the information. And if you're running on LSTM, you do need to understand the state. And if you're running on transformers, you need to understand where you have the channels. Um, so it, once you understand on which dimension and in which way the operation generalize the information, you you can generalize some process that will be able to apply the same algorithms on each one of them.
Hmm.
Um, Sometimes you need to normalize different values because different operation tending to give you values in different scales, but it's technicalities.
Yeah.
The end, when you understand that each one of them is a feature, and the feature is something that's sensitive to pattern or to some complex pattern of few patterns that working together, and you understand that it's a model within a model within a model within a model that's sensitive to all this information, you can apply almost the same techniques. You just need to understand how you're measuring each one of the features. Why, if you're working, for example, in VIT and you have also convolutional models and also a transformer mechanism, you need to understand what is the patches work, and in order to be able how to measure and to understand that this transformer feature are important as this convolutional operation and pattern, and it's just need to trick a bit the techniques. But after you did that and you managed to extract and to represent it in some way in a latent space, you can use this latent space as a just set of features that you manage to extract from your model, from your
Mm.
data, and then it's all the same from there. So yes, you can generalize and you can apply almost the same techniques on any kind of neural network. There is some technicalities and that will require from us to understand exactly how the mathematical operation working, how you can reduce the information without damaging the information you're trying to represent with in certain latent spaces.
And can we do anything when we work with pre-trained models? For example, we a lot of people right now, just the very basic example is again image classification. And instead of taking, for example, a CNN, a convolutional neural network, and training it from scratch on our data set, we will first just download an ImageNet trained model and then fine tune or retrain or do whatever on our data to make it perform better. But then you don't have access to the whole training process. So is there a way to use explainability when you haven't trained the model, just when you already have it well trained and very powerful? Like, is there something you can do to better understand the results if the model is already available?
Yeah. So, well, first of all, we need a better reason to do explainability. If you're trying to explain a specific prediction in productions, of course, you'll be able to take the model and to find the features that took part in this specific prediction, this specific sample, and display the outputs, and then to get some hints about where is the information that the model used when it took a certain prediction. You'll be able to extract those features from all the samples in production at the same moment and search places that the model took decisions from the same features. It's also very interesting, right? If I tell you, you thought that this is a dog, and on these 200 images, you thought that it's a dog from the same reason, from the same features, and this is the differences between them. So it's all a game of how you playing with those features. You don't have to train your model on your data in order to do so. But when you do train your model in data, those techniques can have a very strong um, influence on the development process, right? Because if I can
Mm.
tell you now you have 2 million images that looks exactly the same from this population and 500 images from this population, you're starting to understand how the features expressed in your data set and how the information is distributed in your data set, you can get to much better data sets. We just don't know, and we can't know. You see, like, if we could keep writing deterministic algorithms, we would. Like, you can test it. I can write test for the deterministic algorithm. It's amazing. But the world is too complex, and people understood that they cannot handle the complexity in autonomous vehicle. It's too big. Like, we will
Yeah.
never be able to define and to represent all the complexity, all the patterns that an image can see. So so we understood that, and we went to a process that's searching features. So by definition, everywhere you use neural networks, it's a very complex process that you would not think about all the features. So if you want to think about all the features, how can you make sure that you're testing it properly in the right places? How you can make sure that you have the right samples in the dataset, right? So there is trap over there, and I think that it's a combination of both of them. Like, you need to constantly uh, apply explainability techniques on your model, and by that to learn more and more about the domain you're active in, and then to create a better processes that understand how the information distributing, constantly cure your data set, and constantly find more and more edge cases for that you just need to understand that you need to track after them because they tending to fail because of complexity or ambiguity or anything.
And how would you recommend someone, for example, a student that is working with any kind of model, and doesn't know about explainability techniques, how would you recommend this person to get into this explainability field and just use it to better understand their model and improve their model? Like, yeah, the basics to know when you want to use these techniques to improve your model, and you need to better understand the results. Where can you start doing that, and what do you need to know?
Yeah, well, everyone can use TensorLeap. It's full of explainability tools for that. I think that there is a bunch of great papers in the field that come in to push and help explainability to emerge properly and to provide people the tools they need in order to understand the model, to gain confidence. Now when you're trying to move audit procedures for a new autonomous vehicle, or to get an FDA stamp, you have to provide explainability with it. So there is a lot of work in those fields. I'm not aware of many tools that very mature, that exposing explainability for the development process itself. Probably there is a bunch of them. Um, I think that it's more change of mind. For 4 years ago, neural network in a black box, it was obvious, right? People that claimed, and there is nothing to do. It's too big. We won't be able to explain it, and it's not the case anymore.
Hmm.
It's mostly just people need to embrace and to understand the idea that we need, we can, and we should invest some effort in explaining those models. It's hard, but it must. We cannot release the autonomous vehicle to the street without understanding how they work. And if we tested them properly, what kind of scenarios they will be sensitive to. It's impossible. And I think that people just need to get used to the idea that it's possible to explain them now that we have the amount of computation we can conduct and a bit more advanced techniques to research those algorithms. But go guys, read about class activation maps, about embedding spaces, about similarities of latent spaces.
And should there be a specific team dedicated to understanding and explaining the models that is separate from the people that are developing those models? Or should everyone creating artificial intelligence models also be familiar with explainability and be able to understand the decision of the models they create?
It's a very nice idea. Uh, to have in a team, in a development team, a team that in charge on explainability and team that in charge on modeling itself. Like, if you were trying to optimize the focus of the personas, yeah, I think that explainability is a domain expertise that can be applied on different domains. So I can be a professional in explainability, and I can do explainability to hundreds of models without drilling down into the domain itself. Not necessarily. So professionally, people did front end, back end, DevOps. They split it as well. I do believe that when you working with explainability, you're gaining so much about how the model is working, what kind of features it's tending to land, how the reality is distributing. And I think that no matter how much TensorLeap will do great, intuition will be a very strong part in data scientist world, because the amount of choices you need to make in a day, it's enormous. But I think that explainability can help a lot in building those intuitions. I do believe that we managed to reduce the guesswork they do in 90% a day, like they're doing much less guesses. But it's still important to build an intuition when you're working on a certain domain. So I think that it's very healthy for any kind of data scientist that's working on artificial intelligence to apply explainability on his own model. But it's very interesting. In a big corporation, I can see it happening that, in a few years, they will have explainability teams that will in charge on applying explainability techniques on the models that the company is building.
And do you think right now you mentioned that we are not yet at a level of being able to give like human easily understandable explanations from the model that any human can understand. And so the main background of someone working with explainability should be some kind of data scientist. But also, I assume for very specific cases, you also need an expert in the field to tell you if the model is making the right decision or not, and like if the model's explanation is right or not, you may need an expert in the specific field.
It's not easy to trust those models, especially how they coming out today. And I still think that there is a few stuff we can do in order to gather, and we should gather with a strong understanding. But in order to do that, we need to develop them a bit differently. Um, there is some work that progressing pretty well with explaining models. There is a even a paper. It's really a great one. I think it's called the Mona. Is a textual description of visual features in neural networks. So exactly they did with Clip. They applied on feature maps within the model itself. So it learned and it tells you it's a dog because of the pointy ears, because it found pointy ears and it described those visual features within the model. So it's starting, it will get there at some point, I believe so. I'm not sure how fast it'll be. But I think that before we get in there, we can easily understand, for example, that if a neural network getting decision based on certain features, we can be confident that those features are legit.
Mm,
Maybe, right? So maybe we can map the legit features in the model and the relation between them. Maybe every time you given in predictions for, I don't know, pathology scan, for example, if you found a cancer or not, some of the prediction you can estimate the amount of uncertainty the model has. So models tending to be very confident about their results. It's 100% cow when it's a car, but it's 100% because it usually happens because our data sets are very unbalanced and we very aggressive with our loss functions. So we tending to have a very confident models even when they lie.
yeah.
So, and it's an issue, but there is different ways to tackle this issue. And I think that all those ways are great ways to give us confidence about if the model now needs another professional eyes to validate the prediction it has or not. So, for example, um, you can duplicate the prediction in the training phase to run some dropout, and then when you predict, you legitimately asking the model different models on the same prediction, and then they averaging how many times each one of the prediction happens, and then you get it some kind of confident. Or another models that estimating the error of the model. You're training one model and you're training another model, they're just estimating the error, and then in production you can ask what is is it a dog or or a cat, and then you ask in the other model what is the chances that this model is wrong now. The first model gave you 100%, but the other model can give you a bit more confident. Some work that we are doing in TensorLeap now, we constantly, because we are very strongly into this latent space. So, for example, if we found a very valid and strong population that we managed to characterize well and to understand well and to find all the way that the information is distributed, um, in real time we can predict and understand if it's an example that is common in certain populations. So for example, if we have a latent space and you have groups, we'll take a group, and if the sample fell in the middle, we're more confident about that it's a legit prediction because it's something that you already saw many times maybe. So there is different kind of games you can run on it. It's a bit more complex. You need to generalize it well. You need to understand how many features, how deep they are, how general they are, in order to make it properly. For example, if you have some features that are very high information gain with the input, and you get in a cluster that emerge there, and then a new samples that from production, you still need to have a low confidence in the results because his ability to generalize information is very low in this population, right? So you can normalize it by different techniques. But at some point on, I believe that most of the data set you'll have in production also, you'll be able to feel much more confident and to provide testimonials that it works. So, for example, what we can see in many places, I think that the FDA is already did it, also already asking such as explainability techniques. Take a certain sample, make a prediction, and show me other prediction you made from the same reason, right? So we'll keep progress and develop more and more techniques that will allow us to rely less and less on experts.
So that's you exactly answered my the question I had regarding using explainability. Both we earlier in the discussion we talked about using explainability to improve your results and improve the results basically. And my question was about how to use it for the other side where the user or client just wants some explanation or at least a little bit more details of why the model told you that this was a dog not very long ago. You just had, as you said, models with very high confidence on most most decisions that they took. For example, they they could just say that in an image there was a dog, and with like 95% certainty, whereas it isn't even a dog. It's just because there's grass in the image, and the model is just used to when there's grass there's a dog. So like it's confident, but it's confident in failing. And so it's really nice to see more explainability techniques being used to better explain the results to the users and not just to the people training the models. And speaking of which, I think it may not be possible to do that, but I wonder if there's a way or a specific technique that you can use to explain models that are used through APIs, such as ChatGPT, that pretty much everyone uses right now. Is there something that we can do to better understand their decision or why they answer the way they did?
Well, um, back then, legit techniques in ML were in the models that doesn't have a well explainability. When you cannot apply really well explainability techniques on certain model, many people used to train another model that it's easy to explain and assume that the features they will search will be similar. Um, I think that when you're working with an API, LLM models with an API, there is still a bunch you can do and should. It's a huge problem. Today, it's so easy to come up with a super cool and advanced and strong technology with all those tools, but it's gonna make a lot of issues because we won't be able we're giving up on testing, we're giving up on monitoring, we're giving up on so much. And I think that we just need to tackle it with understanding that it's an API that getting unstructured data and receiving unstructured data from the other end. So maybe it's fine to index the to extract the features. Let's take BERT, for example, and when you ask in this API, extract the features before, when you get a response, extract the feature again, index them to some vector database, have some similarity, understanding, and then you can, for example, monitor when you ask in the same questions in different words, how different is the answer in the unlabeled structure, right? Um, on your vector database, on your latent space, how different the answers are. You can assume that you want to keep on casual and well distributed answers, um, and maybe some more games like that. But all of those are not necessarily explainability techniques because they are not using the model that gave you the
Yeah.
prediction. which is gonna be difficult.
Hmm.
Wonder what they will do. Maybe one day we'll extract another API that monitoring the model itself and providing them explainability in real time for certain predictions. But those models are huge and so complex.
Yeah.
Yeah, it'll take us time together, maybe 4 years.
It's really funny because back in the days, well, it's not even a long time ago, but I always say that it just goes so fast. But like we used to say that we will need, ironically, that we will need deep nets to understand deep nets, and right now it's like pretty much a norm, and you are explaining that using a model on another model's results in a way that this is something very simple and straightforward, and that like we can easily do. It's very funny to me compared to where we were a few years ago, where just doing the deep network was something impossible or very complicated, and now we can just use one to better understand another one. it's it's pretty cool, pretty funny. And so I assume this is also the ultimate goal of explainability AI, is to basically no longer have a black box anymore, is to do anything we can to understand the model we have, right?
Yeah, I think so. I think that, and and the impact has to happen, um, in the development chain, because today when we deploying a new model to production and we running it on our test set and getting 97% accuracy, which is a very high number that we thought that it'll be good if we get to, just because it's an issue. And those 100,000 samples, data sets, test sets are many time oriented and biased to five big populations. So you have five really common population that you're predicting very well on, and hundreds that you're failing without knowing.
Mm.
Um, and they can, represent a very real scenarios in reality that we just will never know that we're failing every time we deploy a new model. And explainability, I think it's the only way that will allow us to work with feature searching algorithms like neural networks and make sure that we're not failing it on new ones. We'll never be God. We'll never understand completely the reality. We'll never be able to do a perfect algorithm that will work on all the scenarios that exist and will be exist in the futures. But we do need to apply the same amount of effort and complexity in testing and constructing those models as they are, right? Because we, to get 97% accuracy on one test set, it's not proving me anything, and I don't think that it's proving anyone anything.
Yeah.
So I truly hope that explainability will allow us to improve dramatically the way we testing those models and the confidence the world have for those technologies, and
And do you think it will also allow us to better understand our own brain? I feel like, I don't know how much they are linked. Well, not, they are, like initially they were linked, but now I doubt artificial neural networks work the same way that our neural network works. But do you think, well, first, are you taking some like cognitive related approaches and use it and try to use them on artificial networks? Did you search into the neurosciences and try to implement some of their ideas, or vice versa?
yeah, yeah, definitely. Well, not vice versa, only from there to ours, because I never got to work on biological neural networks, but maybe one day. I have one data scientist that doing a research about the similarities between artificial neural networks and biological neural networks are how they operate similarly. And we did took some nice ideas from there. For example, when you take a group of patients and you're trying to understand how their brain working differently, so you're creating some kind of self-expressed metrics that giving you some kind of signature of how one brain works on a group of samples. And we apply the same techniques within TensorLeap in order to be able to compare to different models, and it works great. So we do have some, we do took from neuroscience some cool techniques that they used when they researching on biological brains, and I think that there is similarities. It works almost the same, and there is, because of the complexity and the structure, a lot of differences, but it still operate almost the same. Um, it'll take us a while, I think, maybe 20 years, to be able to learn something about our brain from artificial intelligence research, only because the brains that we're working on today are so simple relative to the human brain. We might get there in 20 years, uh, but I think that we are not that close yet. But also, I'm not a huge expert in neuroscience. Only.
It's definitely explainability in artificial intelligence is definitely a very good field to be in if we want to better understand our own brain as well. Just in the well, I don't know how far future, but in the future. How do you see the explainability AI field in 5 years? Will we be able to completely understand the models and build them like very optimally, or will we just progress at the same speed the research progresses on developing new models, so we still won't be able to understand them? What will it be like?
Well, I believe that in 5 years we'll be in a different place towards explainability. I think we'll be much better. People starting to understand again more and more how it's important to have explainability and to understand what you're doing and why stuff happening. Yeah, so I think that in 5 years we'll get to a much better techniques, much progress, tools that will allow us to develop it much better and much clearer. Um, I think it will be commodity to understand your model and to provide explainability with it. The world is gonna invest a lot of effort towards those direction, and we already proved that when we're deciding, this community deciding that something is important, they achieving it. And I think that relative to the gain the world will have from a well defined and advanced explainability techniques towards the amount of work we need to do towards this direction, it's a no-brainer. So I believe that in 5 years, the explainability techniques will be much better than we have today, and I'm pretty sure it's gonna change completely the way we look on artificial neural networks.
Awesome. That's exciting then. And is there any risk of using explainability techniques? For example, when we say that the prediction of a cat is confident, the model is confident by 90% or something, using another model to do that, is there any risk in using that? Like, um, will it lead to being too confident in our models because we assume they are making the right decisions, and in fact it may be just another bias in the other model? Is there any risk of using such techniques, or how to mitigate those risks?
My my belief towards those kind of questions is that relative to the nothing most of the companies doing today, everything they'll do will make it better, right? Like many times we demonstrating the abilities of our platform and people asking us, yes, but don't you create more conformational bias to your explainability techniques, and then you're more biased with the data set you're constructing for that. But I never end up into this direction with, yeah, it's better to not do that. Like relative to the nothing we are doing, right, it might create a bit more conformational bias. You might get confident in explainability techniques that you shouldn't get such confident in, but relative to what we are doing today, it's a huge improvement.
Yeah, that definitely makes sense. And well, my last question, the last question I usually ask is, what is the project you are working on? But I assume you're mainly working of TensorLeap. But if you are doing anything else, feel free to share it with the audience, or else just maybe quickly re-say, like summarize once again, who and why should we use TensorLeap or explainability techniques. Just, yeah, who should we use TensorLeap and why?
Yeah, sure. So, well, no, I'm we working in TensorLeap is a huge product, huge platform. We have there is no chance I left time to do anything else. We work in 13, 14 hours a day. So I don't have any other project. Um, who should use TensorLeap and why? It's people that work in it's data scientists that working on neural networks, training them, monitoring them, and maintaining them on advanced and complex tasks. Right. When a group of people get into such a point that they need to maintain model in production, get confident in what they do, those are the people that should use TensorLeap. TensorLeap is not only a Python library; it's a huge platform. In order to be able to track after hundreds of thousands, sometimes millions of samples and millions of neurons, and to track after all those activation and to index them properly, it's a cloud-based solution. Just for the people that's watching us, it's a cloud-based solution based on Kubernetes, and it can be deployed everywhere, but it's a heavy solution. It's not sample that it's easy to construct in-house. It required a lot of DevOps and software architecture techniques that will be able to detect and to maintain this complex solution. So we did a lot of it. We maintaining 3 or 4 different databases that each one of them uh, really good in indexing and searching specific kind of information like vector databases and big data databases and you know um, different ones, about 4 of them. And we indexing all this information and we applying very advanced techniques on it. So we did already a lot of work in the last 3 years, and we got to a really cool product, I think, that can definitely and transforming the way companies working on neural networks every day. So especially for people that working on your network need to make sure that it will work properly in production, understand where those neural network might fail, and improve the way data sets are constructed. This those are the teams that should use it.
Perfect. And I completely agree with the tool being great, and just the team in general as well. I definitely recommend looking into TensorLeap and explainability in general. I think it's a very important topic. And speaking of which, we will also have a video introducing explainability AI on the channel, so which we worked on together. So I think it will be very cool. And yeah, that's those were pretty much all my questions. If you listening to the episode will like something more in depth on explainability, maybe we can work on some kind of practical tutorial. So let us know if you have any questions or would like any more information related to explainability in artificial intelligence. And thank you very much for your time. I really appreciate it. It's a long time, and it's hard to find this time for you, especially with working over 12 hours a day. So I really appreciate all the insights you provided and your time. Thank you very much.